Hey everyone, welcome to this brand new module, How the Web Works. So, in the last module, we learned about some of the fundamental concepts which is involved in the web. In this module, we are going to understand how those fundamental concepts fit together to make the web work. So, let's get started. So we are going to again see some of the more terminologies which are involved here. So we'll see what is an IP address, what is a domain name, what is it? There is something called DNS, TCP/IP stack, what are IP packets, and we will also look into somewhat more detail about the HTTP protocol. Okay, so what is an IP address? An IP address is a number which is assigned to every device connected to a network that uses internet protocol. So when you say IP means internet protocol. But in general, when somebody says you IP, generally they mean IP address. Later we will see that IP is a protocol which is used in conjunction with something called TCP to get the packets across the internet. We'll see that later, right? But right now, IP address. What is an IP address? So this is a number, right? As we discussed, which is assigned to every device in the network, so that it is sort of an addressing mechanism. Like in neighborhood, we have addresses of different houses, that where we want to go. Similarly, we are having IP addresses which says us that on the internet where we want to reach. Okay, so it represents a unique location on the web. Actually, only the public addresses are going to, there are some private addresses and some addresses inside LAN, but when somebody is saying simple IP addresses, they are going to be public IP addresses. They are going to be unique locations on the web. Okay, now here are some of the examples of IP addresses. So for example, you right now see, right? So these we'll see later what is the structure of IP address. These are called something called IP version 4 addresses. There is something called IP version 6 address also. We will see in detail what is the difference between them. But for right now, if this sort of 4 decimal numbers separated by 3 dots, right, this is going to be a structure of a general IP address. In general, if nobody says what is the version, it is generally assumed to be IP version 4. So basically what happens is that all the computers, all the servers which are on the internet, they are going to have these sort of addresses which are called IP addresses, and using these addresses we can reach those computers, right? This is as we discussed in earlier some of the videos also, that this is a special IP address which is called a loopback IP address, which points to your own computer, right? So using the standard protocols, if you want to launch, let's say, a web server or website on your own computer, but you are doing some sort of testing where you are trying to make your own computer server and you are trying to make your own computer client, which is from your own browser, you are trying to run your own local web server, so which is running at your own local system. So in that case, this is the IP address which is generally used. Okay, so addressing mechanism I was discussing. What do we mean by that? Which means that if there is a computer which is trying to interact with some other computer which is server, then each of them are having an IP address, right? Which means that I have an IP address as a client, and then when I'm requesting a server, then I should say that at which server I'm trying to connect to, from which server I'm trying to fetch some data. So let's say here the destination IP address is something like this, right? Then using this IP address, we will reach this. So that is internally done through IP protocol, right? Which can figure out that where this IP address computer is located. Once we reach that computer, then that computer obviously gets the request, processes the information, but then that computer has to send the data back. But then it again has to know that, okay, where it has to send. There, this IP address comes into picture, that what is the client IP address which is requesting. The server will make that IP address as the destination, and server, when it will give the response, it will give the destination IP address as this one, and the packets of data will come here, right? So in that case, in that way it is going to work. Okay, so now there is a concept of external and internal IP addresses, right? So as I was mentioning earlier, the all the IP addresses are not publicly exposed, right? So these are the external IP addresses which are actually publicly exposed to the world, right? So this is a router at my home, let's say, and I have 3 computers connected to that router. Then essentially what will happen is that all of my computers will not have globally unique, like internet wide unique IP addresses. Rather, only my router is going to have a globally unique IP address, and that router is going to do all the communication with rest of the internet on our behalf. And that's why only this router needs that external IP address which is globally unique. Now, what actually happens is that when I make a request from this computer to some external IP address, let's say whatever, then my request goes here, router makes that request on my behalf, and when the response comes, then this router is aware that which client gave me that request, and it will give the response back to that client, right? But it is also doing inside this local area network, like there is so basically network of computers, right? That is LAN. But if it is a small network, that is called local area network. Let's say it is a small, like 10, 25, 10 computers, right? But internet is also a giant mesh of computers, giant network of computers, right? But here in this case, only this node, the router of the whole internet, my router as a part of the whole internet is having a unique IP address with globally unique, and that is called external IP address. And these IP addresses are internal, right? They don't bother to directly connect to rest of the internet. They are connecting via the router, and that's why they don't need an external IP address, right? And since router is in the middle, the router can figure out that where to send response, etc., right? So now you have a fair idea what is internal and external IP addresses. Now, as I mentioned earlier in the passing, there is something called IP version 4 and IP version 6. When nothing is mentioned, please assume that by default they're talking about IP version 4, right? Now, what is IP version 4 and why IP version 6 was needed in the first place? The problem is that IP version 4 is a 32-bit address, right? As I mentioned earlier, that you see there are 4 letters, right? See, there are 4 decimal numbers separated by 3 dots. So actually, when you see that 32 bits, which means that after every 8 bits there is a dot. After every 8 bits there is a dot, right? And if 8 bit is there, what is 2 raised to the power 8? 2 raised to the power 8 is 256, which means that there can be the number between each dot can be from 0 to 255, and that's why you will always see this number, any decimal number in between them, that is going to be in the range 0 to 255, not more than that, right? Because 8 bits, 8 bits, 8 bits and 8 bits, overall it makes 32 bits. So IP version 4 is a 32-bit address where each of the 8 bits are firstly represented in decimal and then they are separated by dot. This is the convention, right, for IP version 4. Now why IP version 6 was needed in the first place? We will see that 255 to, so basically as I mentioned that 8 bits can count up to 2 raised to the power 8, right? Similarly, 32 bits, what is the total number of bit combinations possible, total number of IP addresses possible using 32 bits? Let's calculate it. Simple, right? You can Google it, like 2 raised to the power 32. What is this giving us? This is giving us 429, this big number, right? This is basically, as you can see, this is million and this is billion. This is around 4.29 billion, and that's why I wrote around here that it is around 4.3 billion IP addresses. Now, at the beginning of the internet, when the internet was born, this was thought to be a pretty big number, and it was thought that it would be sufficient. But now, going forward, we saw with the blast of the internet that even this is not sufficient, right? If every person on the internet is going to have a mobile device, definitely 4.3 billion is not going to be sufficient. On top of that, we will exhaust it much before, because not only my mobile phone has IP addresses, right? My, let's say, some IoT device, my refrigerator can have an inbuilt internet connection, right? All my smart devices, all those sensors in IoT, though everything has an IP address to be reached, right? Now this thing cannot go like that, and that's why we will not be able to deal with all the uses which we require in the internet with only this many IP addresses, right? That's why we needed an insane amount of IP addresses, and that is exactly what IP version 6 does. So by first guess, what you will do, obviously I will increase this 32-bit to somewhat bigger, right? How much bigger? That is where IP version 6 comes in. Let's see. So firstly, the example of IP version 4 address, I already mentioned something like this, 4 octets separated by dots. Now let's come to IP version 6. This is 128 bits, which is a very long number. Why? Because now when I try to find all the possible number of IP version 6 addresses, then this is going to be 2 raised to the power 128, which is like a, I just can't even pronounce it, right? It is a something 10 raised to the power 38, which is a mammoth number which will never finish, right? And that's why in the new age, many times IP version 6 is used, right? And what is the syntax? We'll see that generally IP version 6 addresses are something like this, where you see that all these things, like each of the, I think it's not 16 bits, it will be 32 bits, right? Each of the, no, it will be 16 bits, yeah. So basically you see now, we are having how many parts? See, 1, 2, 3, 4, 5, 6 and 7 and 8. 8 parts. So basically what? We are dividing 128 into 8 parts, right? Which is coming out to be 16, which means each of the parts is 16 bits. And we'll come back to that, how it is represented, and that is separated by a colon, right? So these things are separated by colon, and each one is 16 bits. Now you can see that, okay, this does not look like a decimal number. Actually, this is an hexadecimal number, just for brevity, because hexadecimal can be concisely represented using 16 letters rather than 10 letters like decimal, and that's why it will look something like, so its alphabets will be from 0 to 9. It will also have A, B, C, D, E, F, right? 16 letters. So in that case, and each one of them will represent a number between 0 and 15, right? And that's why it can represent 4 bits, and that's why 4, 48 and 12 and 16. So 4 such letters of hexadecimal can represent 16 bits, and that's why the whole of the 128-bit IP address version 6 IP version 6 IP address can be represented in this fashion. Fair enough. Now we will see what is a domain name. A domain name is a website's human readable IP address. Human readable address. So basically internally it is IP address, but a human cannot go into that much details, right? That, okay, this IP address is like complicated, I have to remember something like this. So obviously these things are going to be complicated. So what a domain name does is that it makes it human readable. I don't have to remember that many numbers. I will simply remember facebook.com, I will simply remember google.com, and internally that will be mapped to some IP address. And how that translation works, we will come next, right? Here simply understand that we can simply put a computer's location, we can simply see that what is the location of a computer by a human readable name, human readable address, rather than an IP address. It's as I mentioned, its simple purpose is to make it easy to remember. Now, domain names are used in URLs to identify which server a specific web page belongs. Obviously, we can do that directly via IP addresses also. But as I mentioned, most of the URLs are composed using domain name because it is easier to remember domain names rather than actual IP addresses. Now, the domain name consists of hierarchical sequence of names labels separated by periods and ending with TLD. Lots of buzzwords, right? So hierarchical and then TLD, right? So let's come back to it one by one. The best example is to understand it using some of the URL examples. So this example.com, right? What is the meaning of hierarchical? Hierarchical means it is sort of a tree, sort of a structure where you say that, okay, com is at the top, let's say, for this registry, com registry, and then there can be google.com, facebook.com, example.com. So under com, many things can come, right? Again, under example, if you have purchased, let's say, example.com, then you can create the next level of hierarchy. Login.example.com, about.example.com, app.example.com. So these are the subdomains. These are called subdomains of a particular. So you see there is a hierarchy. There is a registry, then there is a domain, then there is a subdomain. So in that case, and you can make it even third level, fourth level, fifth level, whatever. Subdomains can be like nested many levels. But you understand the point that there are this last part, this com here .google is actually a TLD. So here the registry is .google, right? There is no .com here, which means that this .google is like a top level in this hierarchy, like .com here, right? And then you can create separated by period. You can create next level of hierarchy as per the need of the application, right? So for example, if you have purchased example.com, you can create whatever subdomains below that, and that is the meaning of hierarchy. Okay, so with this almost we are done in understanding the part where what is a domain name and what is an IP address, but still it is not clear that how that translation is going to happen, how the internet will know that, okay, what this is human readable, this is example.com, but where to go, what is the IP address to find this example.com website, right? That is where the next part, DNS, comes in.